Let's see continuity at endpoints. So now till now we have been seeing what happens for a function at a point. So whether it is continuous or not. But now instead of talking about a point, we want to talk about an interval, whether the function is continuous at an interval or not. So what we did in the earlier videos was, now given a point, at this point we wanted to test whether it is continuous or not. For that reason, we have seen that if you say the value of the function is f of a at that point, let us say f of x, right, then we have found out the left hand limit, which means the function value at a point slightly to the left of it, and then we have found out the right hand limit, which means the function value at a point slightly to the right of it, right. And now if all these three values are equal, we said that the function was continuous. Now we wanted to see, what we want to see is whether the function is continuous over an interval, let's say a and b. So from a to b, we wanted to see whether the function is continuous or not. Let's say this is x and it is a function, okay. Now how to find it out is, a function is said to be continuous over this interval if it is continuous at all the points between them, as well as it is continuous at the endpoints. But coming to the endpoints, we need not worry whether it is continuous to the left of it, because it doesn't fall in that interval, right. So only thing we should be worried about is whether it is continuous to the right of the initial point and to the left of the final point, right. So which means we have to find out the value here, and that value should be equal to the value slightly to the right of it, and we should find out the value here, and that value should be equal to the point slightly to the left of it, right, which means we are going to find out right hand limit at the initial point and left hand limit at the final point, as well as we have to check for the continuity over all the points between them. If you can say that this value is equal to the right hand limit and this value is equal to the left hand limit, and all the points at all the points it is continuous, we can say that the function is continuous over that range or the interval. Now see the definition. In an interval a comma b, f of x is said to be continuous if it satisfies the following three conditions. Now what are the three conditions? F of x is continuous for all x belongs to a comma b, which means between these 2 points a and b, f of x should be continuous. And the second point is, f of x should be right continuous at the initial point. What is initial point here? A, right. Now at this point it should be right continuous. So what is the meaning of it? We should find out the right hand limit and we should find out the value of the function. Now these two values should be equal, then we can say that it is right continuous, right. And f of x should be left continuous at the final point, which means at this point we have to find out the left hand limit, and the left hand limit should be equal to the function value at that point. Got it? So we need to check these three. So what are the three conditions? For all points it should be continuous, and at the initial point it should be right continuous, at the final point it should be left continuous. Now let's take an example. If f of x equal to step x, where step x denotes greatest integral function, then check the continuity on 1 comma 2. So what is the meaning of step x is, if we have a value, let's say 1.5. Now 1.5 lies between two integers, one is 1 and other is 2. Now this value will be given as 1. For all the values between 1 and 2, the value of the function, the step function, will be 1, right. If you say 0.5, now 0.5 lies between 0 and 1, therefore its value will be given as 0, which means for all the values between 0 and 1, the function value will be 0. Now if you see why it is called step function is, it will be like looking like steps, right. So you can see this. For example, if you see this one in the graph, for all the values between 1 and 2, the value of the step function is going to be this one, 1, right. And for all the values between 2 and 3, the value of the step function is going to be like this, right. And for all the values between 0 and 1, the value of step function is going to be like this. So if you see this, it will be like steps, right. So that is why it is called as step function. And as you know, step function is not continuous over a long interval, because there are breaks, or there are holes. If you see it from here to here, it is directly jumping. Therefore for a long range it may not be continuous. But if you see this question, they are asking us to check whether it is continuous between 1 and 2, right. So how can I check it? There are three conditions I need to check. For all the values between 1 and 2, I should find out whether it is continuous or not, and then at the initial value it should be right continuous, and at the final value it should be left continuous, right. So let's see how to do it. First one is f of x equal to step x could be plotted as shown in the figure. That is where we have shown it. Now from the graph, f of x is continuous at all points 1 to 2. Now if you see this, from 1 to 2, between these two, it is definitely continuous, right? There are no holes or there are no jumps. It is a continuous straight line. Therefore, it is definitely continuous for all the points between 1 and 2. So condition 1 has been satisfied. Now what is condition 2? Condition 2 is nothing but we have to find out the right hand limit at the initial point, right? Now what is the right hand limit at a? See this. One thing is f of 1 equal to 1. From that we can see it. And the second thing is we have to find out the right hand limit at 1. So what is right hand limit means is just move to a point to slightly right of 1, which will be 1.00 something, right? Now when you move it, see this, limit extends to 1 plus f of x, you should find out, right? And if it is equal to f of a, then we can say that it is right continuous. Now limit extends to 1 plus step x is going to be f of 1, which is nothing but step of 1 plus something, right? So if you see this value is going to be step of, you can just assume that we are moving it slightly to the right, which means 0, 0, 0, 1 or something like this, right? Now if you see this value will definitely be in the range between 1 to 2, therefore its value is going to be 1. Got it? So we found out that f of 1 equal to 1, and also to slightly to the right of it, we found out the value is 1. Therefore, right hand limit is equal to the function value at 1. So we can say that it is continuous at 1, right? And similarly, we can find out what its left hand limit is, right? Okay. Now if you see the final point and the left hand limit at it, f of 2 equal to 2, and the left hand limit at x equal to 2 can be found out by limit extends to 2 minus step x, right? Now if you find out limit extends to 2 minus, it is going to be limit extends to 2 minus f of x, right? So we can see that limit extends to 2 minus f of x is not equal to f of 2, right? So we can say it is not continuous at x equal to 2. Got it? Okay. Now if you want to see why it is not continuous, look at the value of the function at x equal to 2. At x equal to 2, the value of the function is going to be 2. Now if you take a point which is slightly to the left of it, which means from 2 you have to subtract something, right? So if I subtract, let's say 0. Whatever value is 0, 0, 0, 0, even the least value, it is going to give me something like 1.999 something like this. Now this value is going to lie between 2 and 1, right? Therefore the step function of this value is going to be 1. Got it? So for any value which is less than 2, slightly less than 2, the step function is going to give us 1, right? But the value of the function is 2 and the step function is 1, therefore it is not continuous. Got it? Okay. Now this question can also be extended this way. Since we know that it is not continuous at 2, we can say that it is not continuous over the interval 1 comma 2, right? See, now we found out that it is not continuous over the interval 1 comma 2. The reason is at 2 it is not left continuous, right? So now what we could say is if you just eliminate that point 2, right, it is failing only because of the value at 2, right? Now if you eliminate just the value 2, we can say that it is going to be continuous till this point, right? So from 1 inclusive 1 and excluding 2, whatever is between 1 and 2 without including 2, right, you can include 1. So this is closed and this is open. So from closed 1 to open 2, you can say that the function is continuous. But then when you close it, the function is not continuous. The reason is at 2 the function is actually jumping, right? Now at 2 the function has become 2 and to the left of it the function is 1. That is why we can say that it is failing at 2, but on the other points it is continuous. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science or for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.